Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through alternating current and alternating voltage theory. If this is the first time you are visiting God Academy, please make sure you subscribe and you also share to your friends as well. AC theory, or you can say AV theory, okay? So AC, the word A is standing for alternating, right? So it can be alternating current or alternating voltage, right? Alternating current or voltage. So we use alternating current or voltage for a particular category of voltage and current. In our previous lessons in applied electricity, we looked at DC, right? So the D there was for direct, okay? So when you talk about direct current, direct voltage, it means that everything is direct as is noted, right? So, what do we mean by alternating current or voltage? So, when you say something is alternating, it means it switches between two states. It goes up and down like that, right? So, let me try and model some alternating current here. So, if you have something like this, right? So, you realize that our voltage increases with respect to time. So, time seconds, and I have, let's say, my voltage V here is voltage, and it will rise from zero, move until, let me say here is 2, here is 3, right? So at every point t, our voltage attains a different value, but there is this particular point where it hits its maximum value and starts declining. It declines to zero, goes to the negative side, so I can make this side here E, and I can make here negative E or negative V, right? Like two different values. Then until it hits another maximum. Here I'll make a minimum because at the down part you have the least value, right? Then it continues like that. So that's what we call alternating current. One interesting fact: whenever you are exposed to an electrocution, there are two different types of current or voltage you'll be exposed to. If you are exposed to AC, which is popularly used in our home, so common in our home, your refrigerator, your fan, everything uses the alternating current. So whenever you are exposed to this type of current and you touch and you are being shocked, you realize that at a point you can release your hand, right? So let's say you are here and you touched a wire. Immediately you touch it, it will shock you. But when it is returning, so look at something here. So on our curve, it will rise to a peak. After shocking, it will return back to zero. So upon returning to zero, you'll be allowed to take your hands off. When you talk about DC, which we don't normally use in our homes, but they are in some powerful machines at high magnitude. If you don't know when you touch a direct current circuit, please, you can't take off your hand. It will electrocute you till you die. Let me write something like this. So I have a battery power here, a battery source here, connected to maybe a bulb here. Then accidentally, this side is exposed and you want to touch it with your hand, right? What happens is that you become part of this circuit forever because the circuit is direct and it never stopped or never reaches zero. So please take note of these two things. Whenever you see a DC, it is very dangerous than an AC because if you're exposed to a DC and the magnitude is so high, you are dying, like you are dying. Whilst for an AC, at the point where the AC returns to zero, you are freed. It can take off your hands, right? Good. Now let's go straight to business. When we are talking about alternating current and voltage, there is one problem. Whenever I give you a 5.0 volt battery, you know that the value is what? 5 volts. It's going to deliver a particular amount of current, let's say 2 amps, right? Now, AC or AV, as you're talking about here, is alternating. The value of the current and voltage keep on changing at a particular time until it hits the maximum, which you call the peak voltage or peak current, okay? peak peak current or voltage. So at the peak voltage, our AC then come back to zero. Our AV then comes back to zero. Okay. So meaning that we don't have a particular value since every time our magnitude is changing. So it can be like 0, 1.1 until it reaches, let's say, 16 volts, and it drops down to zero, and it goes on like that. So if we want to characterize an alternating current or voltage, it means we have to choose some particular values that will average the sum of all the different values at all times. So there are two categories of values you are looking at. We have one we call average value. Average value. Then the second one is called root mean square value. Root mean square value. Okay. So when you talk about average value is simply the DC component of an AC, or let's say, I mean, the DC value. So if you take this graph, let me take one cycle of this graph. I'll take you deeper into it. You realize that when I sum all the voltages at all times over a particular period and divide it by the period, I can get an average value for that entire cycle, right? So we use the average value, which is directly the DC value. So if I have an ammeter and I connect it to an AC, the reading on the ammeter is what we call the average value. What it does is it adds all the different changing values over the period measured. That gives us the average value of our voltage or current. Okay. What about root mean square? So when you talk about root mean squared value, so mostly VRMS. Okay. This one is represented as VAVG. Take note of that. So root mean square value is simply um, a value which we use to characterize an alternating current or voltage, but it is defined as the value of a DC, right? So the value of a DC, which when flowing through a given resistance for a given time, produces the same heat as the value of our AC or our AV. So this one is talking about the value that describes the amount of heat that will be dissipated across a particular resistance, the same as the this AC that we are going to calculate for. So these two definitions are equally useful in calculating values, parameters, and all that in an AC circuit. So please, let's see how best we can understand the different aspects of alternating current and voltage, or we mostly say AC theory for short. Okay, so now to start with the whole thing, we need to understand how to solve for average value and how to solve for root mean square value. So to solve for average value, we are going to take the steps one by one. Okay, so for average value, how do I find the average value of my AC? So for you to understand the average value, let me still use the model I have here. First of all, you identify a cycle. Identify a cycle. So this is what I'm going to do. I'm going to draw a rectangular waveform here for us to use to understand this one better. Okay. So I have 0, I have 2, I have 4, I have 6, I have 8, right? Then I have a peak of E. So let's see something. This is what you call a rectangular waveform. So it assumes the shape of a rectangle. Is that not it? It starts from 0, increases a particular point called E. Then after it maintains its value over the period to 2. Comes down like that and repeats. For us to find the average of this waveform, or to find the average value, what we are interested in is we want to identify a cycle. In an AC, it's simply one cycle repeating itself countless times. Okay, for that reason we don't need all the cycles for us to get the average value or the RMS value. So for the average value, we identify a cycle. A cycle is a complete, I mean, revolution, right? So I start from 0. So let me use red. So this signal starts from 0, it rises to E, maintains for 2 seconds, come back to 0, come back to 2, moves down, then it starts from 0 again. So a cycle in a waveform is simply where a signal starts and starts again, right? So it started here and it's starting again here. So this whole section is what we call one cycle. The same will repeat for the others, right? So now let's identify the cycle. Now we've identified our cycle. So this is our cycle up. So this is simply our cycle, right? So once I have this cycle identified, what's the next step? So the next step in finding your average is simply to note the period. Note the period. So you identify the period. What do you mean by period? So in a waveform, when you say a period is simply the time taken to achieve one cycle. So how long did it take the signal to achieve the complete cycle? It started from 0 and it started again from 4. So here we can say that the period is 4 minus 0. It started from here, right? Then it will come and start at 8, right? So it can also be 8 minus 4, which is also 4. So the period is constant for all cycles. So period is simply when a signal is starting and when it's going to start again. You just find the difference in times, and that is all. So once you have identified our cycle, we've noted a period, what do we do again? We find the area of the cycle. Area of the cycle. And after finding the area of the cycle, we simply divide the area over the period, as simple as that. So this gives us the average value. So average value is simply the area of a cycle over the period of a cycle. So take note of that. Mathematically, we can use integration to do this. There are some waveforms which are very hard for us to even try to directly find the area. So mathematically, we can say that area, area, we use integration. Is that not it? So integral 1 over t. So the period is dividing. So 1 over t, 0 to t of a function f of t, right? dt. So this expression means that this is for the area over the period. So summing the area over the period divided by the period. Okay, that gives us all this thing described here. Now let's check the RMS. So for the RMS, it's the same process but a slight differences. So first of all, we identify the cycle as well. Number two, we note the period. So taking note of the period, we are not done. We square the cycle. Okay, we square the cycle. So we square the cycle, and after we find the area of the square cycle, area of squared cycle. Then we divide by period, then take square roots of the expression. That you see, so you realize that the square root part makes it the root mean square, right? So we first square the cycle before we found the area of the cycle. Then after we divided by the period, then we took the square roots. Let's solve these problems, then you understand how this is done systematically. Okay, so let's see something. No, so let me take the mathematical representation for RMS. So VRMS or IRMS, which is whether you are dealing with a voltage or a current, is simply equal to a very big square root. Within it, I have 1 over t, integral from 0 to t, my function of t all squared, right? Et. As simple as that. So it's just summarize the whole process. Identifying the cycle, squaring the cycle, that's the square. Finding the area of the square cycle, then dividing by the period. Finally, you take square root of the whole expression. So please let's analyze this problem here. So I have this rectangular waveform. Then it's something like this. But so I have 0. Let me use red blue. I have 0. I have E. I have negative E. I have 2, 4, 6, 8. So we are supposed to find the average and the root mean square of this signal we have here, a rectangular waveform. Okay, so this one has voltage here, then this is t per second. Okay, at time equals 0, you can see at time equals this interval to 2, then it moves. So this is what we call a rectangular waveform. It has both up and down like this. Let's find the average of this signal, both mathematically and as well as both using the direct geometry or using the mathematics. So now let's see, to find the average, in our previous section, we were talking about the steps. You identify a cycle. So let's identify a cycle. So I'll start from 0, I'll rise to a peak, and the peak is E, right? Then I maintain that for 2 seconds, then I come down to 0. but I'll still step down to the negative of my 2, move down for another 2 seconds and come back finally to 0. Then this is where the signal starts again. So this is what we call a cycle. So if I'm to continue from this side, I'll move up like this, come down and come down again. This is another cycle. So this and this are the same. You just choose one to find your average. Identifying a cycle, we are done. What's the next? Identifying the period. So what's the period? Period T is simply equal to, now it started from 0, ended at 4. So 4 minus 0, which is equal to what? 4 seconds. You could have equally say that 8 minus 4, which is equal to 4, and that is perfectly true. So once we have our period identified or noted, the next thing is for us to find the area of the cycle. To find the area of the cycle, you can see that our whole system is divided into two. I have one rectangle here, another rectangle. So area of rectangle A, so area of A, right, is simply going to give me my height or my length times breadth using a normal geometry. What's my length? My length is simply equal to 0. So E minus 0 is E, right? So E times the breadth is 2, and that gives me 2E. Area of B, you realize that my length here is now negative E. So B area is simply equal to negative E times 2, and that is negative 2E. So my total area is 2E minus 2E, and total area is equal to 0. So the period says that once you find your area of the cycle divided by the period, and you are done. So 0 over my period 4 is equal to 0. So the average um the average voltage of this waveform is 0. So because of this, there is a general rule that whenever you have this symmetric wave, the average is 0, because whatever is here will cancel what is here. Now let's find the RMS of this same thing. Or before the RMS, let's use the mathematical approach to solve for this. So what do we get in this section? So realize that mathematically integral, so 1 over my t, which is 4 seconds, integral from 0 to what? From 0 to 4 of my function e dt, right? So let's see something here. So with this, since I have two different boxes, my interval is not simply going to be 0 to 4, but we will break the interval down, and the interval will simply become what? From 0 to 2, then 2 to 4. Is that not it? Because from 0 to 2, the signal is different from 2 to 4, though the entire period is 0 to 4. So decomposing this, I get 1 out of 4, integral from 0 to 2, e, right, dt, plus 1 out of 4 again, integral from 2 to 4, e, but this time it is negative e. Please take note of that. So everything here becomes minus. So let me make it minus here. So minus. Then let me remove the negative. So I remove the negative. Then I get e dt. So at this point, if you are solving this mathematically, you realize that if you have an integral with respect to e times t, what's that? So you get et 0 to 2. Is that not it? When I put 2 here and minus 0, I get 2t, 2e, right? I have my 1 over 4 outside. You keep it. Minus here too, you have et, right? Et 0, 2 to 4. So you put in 4 minus 2. So it's still 2t. So I'll get this section to be. So I get this section to be 2t. So this side too is minus 2e. Then our 1 over 4 come out. So here we get 1 over 4, 2e minus 2e, which is 0. Therefore, our average is 0. So you've clearly seen that mathematically and geometrically our answers are equal. So let's find the RMS of this waveform. So the RMS says that you identify the cycle, identify the period, which all of them have been identified. You square the cycle. So let's see the effect of the squaring of the cycle. So if I want to square the cycle, realize that there wouldn't be any negative parts. My cycle will be positive, but my e will become what? Squared, right? My e will be what? Simply squared here. So there wouldn't be any negative parts. So the cycle would then become something like this. So like this. So please take note. All the negative will fill up the positive, and we get positive stuff here. So because of that, to find the area of the new area with regards to my RMS, I'm going to have First of all, the area of A, so my both my A and B will be on top, okay, so from 0 to what, 4. So to find the area of A alone, it's simply going to be what? 2 times E squared, because right now my peak voltage, which was E, has been squared, so I have E squared, so I have 2 times what? E squared. Then you realize that for the RMS, for the B part, I'm going to have the 4 minus 2 as my length, so plus 4 minus 2 multiplying what? E squared, right? So this ends up giving me 4E squared. Then the rule says that after finding the area of the square cycle, we divide this by the period. So we get 4E squared over the period 4. 4 cancels 4 and I get E squared. But we are not done. The next thing is to find the square root of our answer. So square root of E squared is simply equal to A. Therefore, our RMS value is simply equal to E. As simple as that. Now let's use our mathematical approach. So the mathematical approach is simply going to be, since now we don't have a negative part, I'll take a straight integral 1 out of 4. My square root is outside everything. Integral from 0 to 4, right? Then the function E squared dt. As simple as that. If I integrate E squared with respect to dt, I'll get E squared c 0 to 4 like this. Everything times 1 out of 4. And my square root, everything outside, half. So this now, when 4 goes here, it's 4 minus 0. So you get 4t squared, right? Is that not it? Times 4, 1 over 4. This cancels, that side is what? T squared. You already have our square root outside, so this becomes what? T. Is that not it? Sorry, this becomes E, not E, not T. It becomes E. So here is actually E. E, sorry. So this is, so the answer is what? E, as you saw rightly here. So whether mathematically or geometrically, you should get the same answer. Yes, now let's solve one last example, then we close it for waveform, right? So find the average and RMS of the waveform below. So this is my waveform. I have this. So 0, I have 2, I have 4, 6, 8, 10, 12. And up here I have 10, okay? I have negative 10 down here. This is time with respect to seconds here. So we have to find the average and the RMS of this waveform we see nicely here. Let's start with the average. With the average, you realize that the first thing is to identify our cycle. Our cycle starts from 0 as this, moves here, come here like this, ends here. Then it starts again here. So meaning that we start from 0, then we end at what? At 10. Is that not it? We start again at 12. So therefore, we are going to have our period to be simply equal to 10 minus 0. And that's equal to 10 seconds. Well noted. At this point, you find our area. Our area here can be decomposed into, the shapes can be decomposed. So I can create a triangle here. I can create another. So there's one triangle here, then there is a rectangle, right? So here, the 4 is attached here. So please take note, the 4 is here, not here. Okay. So therefore, I can break my area into A, B, then not C. That's not it. A, B, then C. So for this one, my area A is simply equal to length times breadth. So 4 minus 2 multiplied by my height, which is 10. And that is giving me 20. My area B is simply giving me length times breadth. So 4 to 8 is 4 times 10. And that is equal to 40. Area C is on the negative side. Negative 10 times what? 10 minus. So 10 minus 8 times negative 10. That's going to give us negative 20. When I sum everything, I'll get my total area to be equal to 40. Simple as that. So if the total area is equal to 40, my period is 10, my average is simply equal to 40 over 10. That is equal to 4 volts. As simple as that. Let's find the RMS. To find the RMS, I'll square this cycle. So you realize that when I square, the down one will come up, right? So I'll have something like this. where my this side will vanish away. So here we are going to use a simple approach. You realize that you square the cycle. When I square the cycle, this 10 becomes what, 100. So square cycle, this side become 100. Okay. Once it becomes 100, we can find the area of the square cycle. What's the area of the square cycle? The first area now becomes 2 times 100. That is what, 200. Remember, it's the same thing as we have here. Okay. But there is one problem here. We can't say it's 200. There's experimentally or mathematically solved principle that whenever you want to find the area under the square cycle and the shape you have is a right angled triangle, then it follows a general formula. So if the area under the square cycle is a right angle triangle, then it is h squared b over 3. H squared b over 3. So where our h is simply the height, the b is this, and 3 is just a constant. So therefore the area of a is simply equal to a squared, which is 10 squared, times the b, which is 2 over 3. Right? That will give us 100 times 2, 200 over 3. That will be the same area for c, right? So 200 over 3 plus 200 over 3, that will give me 400 over 3. But the area of b is simply going to be 4 times what, 100. That will be 400. Is that not it? So we have our 80. So that will be 400. Okay. So with that, I'm going to have 400 over 3 plus 400. Right. So this 1,002 2,600 over 3. Then once you find the area under the square cycle, you divide it by your period, and the period is 10. So to take away 1 0. So I'll have square root of 160 over 3, and that should give me my answer, 7.3. So this is all that we have in this lesson. See you in the next lesson. But please, if you haven't subscribed to this channel, do well to subscribe and you share to your friends.